So it was just on the board. Okay. So we were talking about the different types of exocrine glands in this particular instance, and I know that they're exocrine. Why? What do they have? What do they all have? Ducts, right? So all of these examples are exocrine because they're secreting their substance into a duct, and then it's being transported somewhere. So in the case of sweat glands, that would be to the surface of the skin. In mammary glands, right, that's towards the nipple, so that the baby, when it suckles, it can uptake in the milk. And then the stomach or the gastric glands would be in producing gastric juice, which includes strong hydrochloric acid. So these are just some examples of the types of exocrine glands. And notice that they talk about the tubular and the alveolar. And the alveolar just means that they have this structure rather than being straight. Remember, we did a little drawing where we showed where it can be like this, right? And so that's the alveolar. Okay. Tissues, chapter 4, and then we're going to move to the skin, yes. Okay. So we also can classify glands, exocrine glands, as being either merocrine or holocrine. So you need to write down merocrine and holocrine. So these are types of exocrine glands. The most common type of exocrine glands are the merocrines. And so this is where they just secrete their products via exocytosis. And so what this means is that they're producing maybe an enzyme, and the enzyme gets packaged in a vesicle, and the vesicle fuses to the outer membrane and releases its substances into the duct. So this would be like your gastric glands. They would be examples of merocrine glands. This is also like the mammary glands, so they are producing milk, and this is also the sweat glands. The only actual type of holocrine gland that we have in our body are the sebaceous glands, and we'll talk about these when we get to the skin. Oops, sebaceous glands, and they're in the skin. And these, instead of secreting their substances via exocytosis, they actually fragment the cells. So notice that the cells bleb off little fragments, and this is what is referred to as sebum. Okay. This sebaceous glands tend to be associated with hair follicles. So they keep the hairs lubricated, the hair on your, it's the reason why your hair gets oily, for example, if you don't wash it. But it's also the reason why our skin does not dry out and crack. So it's kind of interesting, as you get older, your skin starts to get drier. And so sometimes in the winter, and if you work outside a lot, your knuckles will crack open and bleed, right? And that's because you don't have enough sebum to lubricate the skin to keep it from becoming brittle and cracky, right? And that's a bad thing because you can get infection that way. So notice that these cells are undergoing mitosis right here. So this little diagram shows that the cells have to be continually replaced because it's the cells fragment and produce their product. So this is also what gives you pimples and acne. So this would be some of what is in like a white head on the surface of the skin. So that would be your sebaceous glands. Okay, so we're going to move on to the next type of tissue. So all of what we talked about previously was epithelial tissue. So now we're going to talk about connective tissue. And like it suggests, it in some cases connects one type of tissue to another, which we'll talk about some examples of that. But really the characteristic of connective tissue is that we have cells within a non-living matrix. So the cells produce the non-living matrix, and then they reside in there. And the other thing that connects the connective tissue together, so the reason why they're all called connective tissue, is it's derived from a type of embryonic tissue called mesenchyme. That's a mesenchyme. So this is an embryonic tissue. So the bone, your cartilage, your fat, your blood is all, we could all define those as cells within a non-living matrix, and we could all say that all of those different types of tissues are derived from mesenchyme. And so that's why connective tissue, even though when we think about blood and bone and fat, they're very, very different in their structure and their function, but they have all of those two things that are similar to them. Okay, so that's why they're classified as connective. Okay, so when we look at the matrix, we have what is called the ground substance. And one of the things that is in the ground substance is what is called a proteoglycan. So what this is it's actually a protein that has a lot of carbohydrates. So if you think about glucose is a carbohydrate, it's a protein with lots of carbohydrates attached to it. And what the proteoglycan does is it traps water. And that is really important because we do not want our connective tissue to dry out. So sometimes connective tissue does dry out, especially as you start to age, like the menisci in your knees or the intervertebral discs between your vertebrae. They start to dry out, and then they don't function very well, and then they can actually start to tear apart, and that can be really bad. It can lead to lots of joint problems. And so if we look at a diagram, this is a picture. You don't need to memorize this picture, but this is the protein, right? And then these are the carbohydrates that are attached to the protein. And it creates this kind of a network that attracts water and then traps it. So some of these terms you might have seen, because there is in the industry what is referred to as joint nutraceuticals. Right. So if you go to Bi-Mart, even if you go to Safeway and you go to the nutrition section, you'll see that they have these supplements that you can take that supposedly will help with your joint problems. And so you might, for example, see glycosaminoglycans or just glucosamine, right? So you might see that in the joint nutraceuticals. You might see hyaluronic acid. And you might see also something that's called chondroitin, specifically chondroitin sulfate. So there is a little bit of, they're kind of expensive to buy, right? And there is some question as to whether or not they are, they actually work. Because when you take in these nutraceuticals, you obviously break them down, right? So you break them down into their components before you absorb them from your small intestine. So for example, you don't directly absorb hyaluronic acid, and you don't directly, oops, I spelled that wrong, hyaluronic, sorry, the A goes here, hyaluronic acid. You don't directly absorb hyaluronic acid or chondroitin sulfate. Chondroitin sulfate is sometimes taken from the cartilage of sharks, for example. It's also found in bone broth. So like if you were going to take a bunch of bones and boil them for long periods of time, you get a bone broth that some people believe helps with their joints. And so the question is whether or not that really becomes incorporated and actually really helps your joints. But so these would just be supplements that you could possibly take that might indeed help with that. Does anybody take these on a regular basis? And like when you get older, okay, the first time you start to feel your aches and pains of your joints, you might think, oh, maybe I should try that and see if that helps. Okay. So this is the ground substance. Okay. Now within that ground substance, we also have fibers. One of the most important fibers that we have within our connective tissue is collagen. What type of molecule is collagen? Is it a protein, a carbohydrate, a nucleic acid, or a lipid? Does anybody know? Remember? It is a protein. So we call it a structural protein, and it's really important in the bones. It's the primary fiber in the bone that gives the bone its strength. And so this is very strong. Okay. We also have elastin. This is also a protein. And elastin has a different type of function in that it is able to absorb mechanical energy like bending. So it's like rubber. So if you bend it, it will bounce back, right? And so that's important in some of our connective tissue, like our outer ear. For example, when you bend it, it bounces back, right? So it's elastic. Okay. So this absorbs energy and bounces back. Okay. We also have reticular fibers. And when you see reticular, you want to think network. So these are actually small branched collagen fibers that create a network. So branched collagen fibers. And it is a network. So if you think about some places in your connective tissue that this might be significant, this would be like in the bone marrow. So the bone marrow is where our blood is produced. Our red blood cells and our white blood cells divide from and specialize from stem cells. But we also have lots of reticular fibers in the spleen, for example. So we're going to talk about the spleen when we get to talking about blood, because the spleen is where red blood cells go after they become old and damaged, and the spleen can break them apart and break them down and help in the recycling of those red blood cells. So those are two places where you would find reticular fibers in organs and in connective tissue within organs. Okay. So besides the matrix, we have cells. Okay, so the matrix is made up of the ground substance and the fibers. So this is on the same level in my indentation as the matrix. Okay. So when we talk about cells, they oftentimes have an ending. So I'm just going to use bone cells. So example, bone cells. Okay. So bone cells that are mature and are residing in the matrix and just maintaining the matrix are called osteocytes. So notice I put osteo meaning bone, the site means cell. So this is a mature bone cell. Okay. Bone cells that are not mature, which might be found in growing bones, are called osteoblasts. Okay. So a blast means that it is putting down matrix. So it is depositing matrix. So it is building connective tissue. Okay. So that's the blast part. And then we also have osteoclasts. And so the osteoclast means that it is breaking it down. Oops, breaking down the matrix. Okay. So remember that our skeleton is replaced like every 5 years. Really interestingly, some of our bones that are under greater stress are replaced more frequently. So for example, your hip bone, the femur where it comes into your pelvis is replaced like every 6 months. And so this is the reason why we have to use our body in order to build strong bones, because the bone will respond to mechanical forces. So the more weight-bearing activities you do with your bones, the stronger your bones will become. And so this is why when people go bedridden, or when people go to outer space, their bones, when they're replaced, the skeleton is much lighter. Specifically, when you go out to outer space, you don't have gravity, and so your bone density decreases, and your skeletal system actually becomes lighter. And so that's why they try to exercise in space in order to keep their bone density, so that when they come back down and they step off, whatever, they don't break their bones just by stepping and using their skeleton with normal gravity. Okay. So those are examples of cells. Okay. We'll talk about the cells when we talk about the different types of connective tissue. So this is an example. This is just a typical type of connective tissue. The most common type of connective tissue in your body is the kind that just connects one tissue to another. So example would be the skin, and all of your epithelial tissue has a very specific type of loose connective tissue that resides underneath and connects it to the rest. And sometimes that is referred to as fascia. So if you think about like if your massage therapist is like working your fascia, what they're doing is they're working that connection between the skin and the muscle, and then one muscle and another muscle, right? So it's like it connects muscles together. It's the muscle fascia, for example. So here we have some different cells, and we'll talk about different examples of this. This is a fibroblast. So the fibroblast is what is creating the matrix. And so hence you see it laying down this type of fiber, which is called a collagen fiber. Collagen fibers are white. And we can sometimes see collagen fibers when we have scar tissue, because sometimes when our tissue repairs itself, it doesn't regenerate, but it puts down fibrous connective tissue, which has collagen in it. So if you have a white scar, then what you're visualizing in that scar is the collagen fiber. So you'll notice that the elastic fibers are darker in color, so they're not white. Okay, and then we have the reticular fibers, which are branched. Okay, so there is a group of connective tissue which is called connective tissue proper. And it doesn't include bone, and it does not include blood, and it does not include cartilage. Okay, so you're like, well, what does it include? Because I thought that was, what makes up connective tissue. So when we look at connective tissue proper, we have loose versus dense. So what these refer to is the number of fibers. So if it's loose, what that means is that the fibers are kind of, loosely found in the matrix. If it's dense, that means there's lots of fibers in it. Okay. So the loose connective tissue includes areolar connective tissue. This is the most common. Okay. most common type of connective tissue in your body, because this is the one that connects one tissue to another. And we'll look at that in a little bit more detail. We also have adipose. And so what is adipose commonly called? Fat. Okay, so this is fat. Okay, and then we have reticular. Okay, so all of those would be considered loose. And I didn't leave very much room for my dense, so I'll put the two denses. There's only two. There is regular, dense connective tissue, and there is irregular. Oh, I forgot one, sorry. Loose, there's another one, and this, I'll just put it off to the side. This is called, oops, sorry, it's over here, dense. It is called elastic. Sorry, I meant to put it over on this one. Okay. So regular means that the fibers are lined up, right? They're in a regular pattern. And so this would be like tendons and ligaments. So tendons connect muscle to bone, and ligaments connect bone to bone. So like your elbow joint is held together by ligaments, and then the muscles also insert onto the bones, the forearm and the upper arm bone, using tendons. Okay, but ligaments help to hold bones together. So they actually think of suture, right? So a ligament would be like threads that hold something together. Okay. Irregular is the joint capsules. So we're going to talk about joints in more detail, so we'll talk about this when we get there. But a joint capsule creates a space, because most of our joints are synovial joints. And so most of them have a space, and the synovial fluid inside helps to lubricate the bones so that they don't grind against one another. So joint capsules would be dense. And then we also have elastic, and some of the places, well, one of the most in places where dense elastic connective tissue is found is in the aorta. And the aorta is a major blood vessel that comes out of the heart. And so it needs to be able to expand when the heart pumps and the blood moves out through the aorta. It needs to be able to expand, and then it needs to be able to contract to force the blood to move on to the other smaller blood vessels. And so elastic would be in the aorta. Okay. So if we look at some diagrams of these, so if we look back at the areolar, notice that the type of cell that is found in there primarily are fibroblasts. So this is the areolar. We have fibroblasts. So this is under the epithelial tissue. So under epithelial tissue. It surrounds organs. Okay. It's also important in inflammation because it can store water. So when your tissues become inflamed, fluid is lost from the circulatory system and it goes out in here. So this plays a role in inflammation. Because it holds water. So what is swelling called? Like if you get injured and your knee swells up, what do they call that? Inflammation, but it has that tissue swelling has a specific name. Let's even remember what that's called. Tissue swelling is called edema. Sometimes it can be good if you're needing to get extra fluid and white blood cells and all kinds of stuff to the injured site. Sometimes it's bad. So like people with diabetes sometimes will have inflammation of a whole limb. So one leg will just swell up because their blood is not functioning properly in taking up the fluid. And so then you can get a swelling that is in all the tissues. And you're like, well, can't you do something about that? Can't you drain it? No, because the swelling is actually in this areolar connective tissue that kind of surrounds all the structures. And so then you'd have to do something else to get the water out. Okay, so this is the fat cells. So this is adipose tissue. And the cells are adipocytes or adipocytes. ADI, adipocytes. And one of the interesting things about fat cells is that you do not replace them. Typically, when you're a child, you get a certain amount of fat cells that you're going to have for the rest of your life. And then, so when you gain weight, your fat cells fill up. And when you lose weight, you don't lose the fat cells. They just squish back down. And so you don't actually tend to lose fat cells when you lose weight. So that's why, you know, surgically removing fat cells is kind of significant, right? Because that's really the only way to get rid of them would be a liposuction where you actually remove them from the body. Okay. So when we look at these store triglycerides. Yeah. I don't know if they even know how that works yet. So, and I'm sure that if like you gained a lot of weight, there is the ability to add fat cells, but in general, people just, you know, if you maintain a relatively constant weight, like 15 pounds more or less, right, gain or loss, then you're not going to gain fat. So I'm not sure about those people that become really, really big, what happens when they lose weight and if they're more likely to gain it back because they have more fat cells. They also found, interestingly, that adipose tissue is actually capable of producing hormones. So does anybody know what hormone adipose fat tissue produces? It produces leptin. So one of the really interesting things recently is we've discovered that not just endocrine systems produce hormones, but even your bones are believed to produce hormones now. And fat cells are used to produce leptin. And leptin helps to regulate appetite and metabolism. So leptin regulates appetite and metabolism. So if you eat, you know, regularly and frequently, your body will produce leptin, and that will decrease your appetite because you just, you know, you're eating three good meals a day, and that tends to boost your metabolism so that you burn it off. And you might have experienced the effect of leptin. This always happens to me when I'm like at a family dinner because, you know, I don't know why I notice it more when I'm at a family dinner, but like Thanksgiving, right? So you eat a big meal and then like half an hour later, you're just hot, right? And it's just so hot inside. And all I have to do is I just have to get out and go for a walk, right? Because I'm so hot. And that's because after I eat, my fat produces leptin that boosts my metabolism so that I will burn off those calories so that I can relatively maintain a constant set point in your weight. Because if you think about it, weight is also a set point, just like body temperature. And so we want to have a mechanism to the negative feedback mechanism, right, to kind of maintain it. We don't want to, gain 50 pounds, in 2 months and then lose 50 pounds in 2 months, because that would just be too much of an increase and a decrease, right? So we want to kind of maintain a constant level. Okay? And so leptin tends to do that. So the triglycerides are fat, right? So this is animal fat. So if you look at skin, if you're looking at chicken skin, for example, chicken skin has a layer of fat underneath it. If you look at, a steak, sometimes there's fat attached to it, and that is adipose tissue. So the interesting thing about this is white fat. Now, if you take a dissection class, like you're dissecting an animal, sometimes this fat is also a little bit yellow. Oops. So I'll put can be yellowish. Right, so if you're dissecting a cadaver, for example, you'll notice that the fat can be yellow. And the reason is that there is a vitamin that's called beta carotene. And this is what gives fruits and vegetables their orange or yellow color. And it's also what can give your skin a yellow color if you eat too many carrots or if you eat too many oranges. If you eat too much beta carotene, it sometimes gets deposited in your skin and in your nails. Okay. So beta carotene is an antioxidant. Right? So white fat would be breaking down those triglycerides and releasing them. And so sometimes that produces free radicals, which can damage cells and tissues and DNA. And so beta carotene is an antioxidant for that. So we can put beta carotene in our fat to help protect it against free radicals that are produced when we metabolically take triglycerides and we start to break them down to produce energy. Okay. Now, this can be subcutaneous. So what does that mean? Under the skin. So cutaneous means skin, sub means under. And this plays a role in insulation. So insulation can help keep you warm because it will decrease the amount of heat that's lost to the environment. So if you think about aquatic mammals, like whales, for example, they have a huge amount of subcutaneous fat. It's called blubber. And that is because you lose more heat to an aquatic environment than you do to a terrestrial environment. So if you're in cool water a lot, you might actually gain more subcutaneous fat in order to prevent heat loss. Okay? So that is important insulation. Another function of it is it can be around organs. Oops, organs. And it can cushion the organs. Now, there is another type of fat, which is really interesting, and it is called brown fat. And brown fat is capable of producing heat. So if we are cold, what typically happens to our body? If like we're really cold, what typically happens to our body to increase our body temperature? We shiver. That has nothing to do with fats, right? That has to do with skeletal muscle. So skeletal muscle causes heat to be released. Well, in some organisms and in our babies, our newborns, they have a lot of brown fat. So if we look at the distribution of brown fat in a baby, okay, this is where it is distributed in their bodies. And so interestingly, this is why, if you've ever noticed or been around a newborn, they just kind of radiate heat. They are warm. They typically tend to be really warm, right? But they're not shivering. So even if it's cool, they don't shiver. And so the way that they're getting heat is that the brown fat is using energy and converting it into heat to help to heat the body. And notice that it's around here, the kidneys, which in this case, it's around the organs between the scapula. So these would be the kidneys. This is the scapula. And then if we look at where this is found in us, oops, I don't have a picture of that. So in our bodies, in the adult body, I had a picture of that. No. Okay. So in the adult body, it just tends to be right around the clavicle. So we tend to lose most of our brown fat, and it tends to reside right here. But it is believed that some people retain more brown fat than others. So some people just tend to have a high metabolic rate and they tend to run hot, right? So they tend to release a lot of heat and they don't tend to store a lot of fat. And so there is some question as to whether or not you could increase your amount of brown fat by decreasing the temperature of your environment. So a few years back, I don't know if you remember this, but people were advocating that you turn down your thermostats at your house to like 65, right? And then just kind of be in a cool environment. And the hopes would be that you would produce more brown fat, and then you could eat more without eating fat, right? So you could eat more because you would just burn it off, right? So that would not be a good strategy if you didn't have a lot of food, right? If you're poor and malnourished, it would be a really bad strategy, right? But for us that live in this affluent environment where food seems to be too many calories, right? That might be an interesting idea. So one of the things that's in the brown fat, right, are mitochondria. So mitochondria are what break down the products of the triglycerides and convert them to ATP. And they produce energy in that fashion as well, and then they release heat. So the reason why they are brown is because of the presence of the mitochondria. So that's why it looks different than the white blood cell. Or not blood cell, the white fat cell. Okay. So this is a diagram of the connective tissue that is found in the spleen. So notice that you have the branching reticular fibers that create a network for the cells to reside in. And one of the things that is found in the spleen are white blood cells. And those blood cells are important in breaking down the red blood cells. And the reticular connective tissue is also found in lymph nodes. And so your lymph nodes would have macrophages or white blood cells in there that can tell when you have an infection, and that will proliferate and cause the swelling of the lymph nodes in your body when you are sick. Okay, so dense connective tissue includes tendons and ligaments. These tend to be white in color. Why? What is white that makes them white? Ugh, God, I can't spell today. How do you spell color? Color. I want to spell it French way. Okay, color. White in color. What makes them white? What fiber? What makes your scar tissue white? Collagen, yes. Okay, so collagen fibers. So the collagen fibers run in one direction. So they're arranged like this, right? And it makes this tissue very strong, having the collagen fibers line up in this way. The tendons specifically are a little bit more stretchy than the ligaments, but the ligaments do move a little bit, right? And so it can stretch, so it's important that the tendons and the ligaments, their collagen fibers, are running in the right line for stretching. So this would be like connecting a muscle, right, to a bone. All right, so if this is my bone, I didn't write that right, very good. Where would this be? I don't know, sorry. My drawings need a little work here. Okay, so the muscle and the bone. Okay, so if we look at the diagrams of this in your book, the images, right? Collagen fibers, here they have dyed them pink, but notice that they're running in one direction. Okay, this is what I was actually kind of trying to draw. So this would be your biceps tendon that connects to the humerus, right? And actually connects over and into the onto the scapula too. Oh, you know, they would be dense connective tissue too. So the vocal cords are white, right? And so they would be this dense connective tissue as well. Good question. Okay, so irregular connective tissue would look like this. So notice that the collagen fibers are kind of going in all different directions, right? So that's the irregular part of that. So this would be dense irregular connective tissue. That's the joint capsule that surrounds the shoulder. And then we talked about the elastic, right? So this shows the elastic fibers, which are darker in color and are staying here. So notice that the elastic fibers are in the connective tissue of the wall of the aorta, so that when they are pressed against and expand, they will press back, right, and help to propel the blood through the blood vessels. Okay, so that is connective tissue proper. Everything that we talked about was the proper, right, the connective tissue proper. So now we're going to talk about other types of connective tissue. So one of these is cartilage. And we're going to spend more time on cartilage when we get to the skeletal system. So we'll talk about the different places that we find cartilage in our skeleton. But cartilage, one of the problems with cartilage is that it is avascular. And what do you think that means? A means without. No blood vessels. Good. So this is no blood vessels. So blood vessels are good because they bring nutrients and oxygen so that tissue can repair itself, right? So one of the problems with our cartilage is it does not easily repair itself. So if you get damage to the cartilage, it is actually, in some sense, worse than when you damage a bone, right? When you break a bone, bone is vascular. Bone has blood vessels innervating it and carrying nutrients, and bone can repair itself. But cartilage doesn't repair itself very easily, right? So oftentimes when we get a tear in the cartilage, like in your knee, you have to go in and surgically repair it because it's not going to repair itself anytime soon, right? So it's avascular. So the types of cells are called chondrocytes. So chondro means cartilaginous. So these are cartilaginous cells. So bones have osteocytes, cartilage have chondrocytes. We have different types of different types of cartilage, right? So we have hyaline cartilage. This is the most common. And in fact, this is what your skeleton is composed of as an embryo. So we start off, our bones are actually composed of hyaline cartilage. And then as we develop inside the muscle, or the mother, excuse me, inside the mother, the cartilage is actually replaced with bone. So that the ends of our bones are actually cartilage. And so when you're eating a chicken bone, for example, the gristle, when you eat off the end of the bone, you'll notice that there's white stuff on it, right? It's a little bit softer. That's the hyaline cartilage of the bone that remains after we become adults. Okay. We also have elastic cartilage. And this would be like in our outer ear. Okay. And then we have a type of cartilage which is called fibrocartilage. And this is in our intervertebral discs. Okay, so those are the discs that sometimes herniate. I think, sorry, this should be discs. Discs with a C. Intervertebral discs. Not a K. Okay. This is also found in your pubic symphysis. So your two pubic bones come together in the front of your pelvis, and there is a joint there that is a little bit movable, but mainly, hopefully, doesn't move too much. When people are pregnant, that becomes really loose, and when they give birth, that has to actually separate a little bit and become actually even more mobile. So the pubic symphysis is fibrocartilage, not ligaments. So this is an example of a location of hyaline cartilage. Hyaline cartilage looks glassy because you can't actually see the collagen fibers, but they are found in here, right? So the collagen fibers would be in the matrix, but the cells sit in a space in the matrix. So this would be the space, and inside that space, we have the chondrocyte. That space is called a lacuna, or a little cave. These are the costal cartilages that connect the ribs to the sternum. A little bit more flexible than if your entire rib cage was just composed of bone. So we're going to talk about bone a little bit today, and bone is another type of connective tissue, obviously, but it is ossified. So we have an ossified matrix. So what that means is that the matrix becomes more solid and hard, and the bones are more brittle than cartilage. And so ossified means that we have a not organic matrix, but we have a non-organic component to the matrix. And this would be calcium phosphate salts. Right? So this is the mineral component of your bone. So it does have collagen fibers. Collagen fibers are super important. It's why the bone is white. It's why the bone is really strong. But your bone tends to be a little bit more solid because of its mineralization. So the calcium phosphate salts make the bone more rigid. Okay, than if our skeleton was just composed of connective tissue or cartilage. Sharks primarily have a cartilaginous skeleton. So even their, their vertebrae are composed of cartilage rather than bone. So we're going to talk more about the structure of bone in lab this week. But one of the interesting things about the bone, compact bone specifically, is that it has this interesting arrangement. And this arrangement allows for blood to come into the tissue. So in the center of all of these circular canals, which are sometimes called osteo, what are they called? Can't remember exactly what that's called. We'll talk about it in lab. They have these central canals, and this is where blood vessels come up. So blood vessels come into the bone. So bone is living, and it is very vascular, and it delivers, the blood delivers nutrients. And then we have these little osteocytes that sit in this calcified matrix, this hard matrix. And they also sit in that fluid-filled space called the lacuna. And the arrangement of the circular arrangement that you see here is due to the orientation of the collagen fibers. So that's kind of why it looks like a bullseye. So this is through compact bone. It's not through the center of the bone. The center of the bone has a cavity in it, but this is not what we're looking at. We're looking at a piece of solid bone, and this is what you would see as it's in its structure. Okay, last one. Okay, so blood. Blood is connective tissue. So we have cells within the blood plasma. Right? So the blood plasma would be the matrix. The types of cells that we include erythrocytes. This is the name for the red blood cells. They are red because they have a pigment, a respiratory pigment in them. Does anybody know what that respiratory pigment is called in red blood cells? What makes the red blood cells red? Not oxygen, it's what binds. Oxygen binds to what molecule? What molecule has iron in it? Anybody remember? Hemoglobin. Right? So this transports oxygen. The erythrocytes are the most abundant cell in the blood. We have another type of cell in the blood, however, which are called leukocytes. So these are white blood cells. The white blood cells that you need to be familiar with to understand the next topic, which is inflammation, would include macrophages. So these are white blood cells that eat other cells. So these are large phagocytic cells that eat debris. And dead, or maybe eat debris and microbes, we'll put. So they would eat bacteria, for example. Another type of phage in our leukocytes is what is called a neutrophil. Okay. So neutrophils are another type of white blood cells that are a phagocyte. So neutrophils and macrophages do essentially the same job. It's just that the macrophages are bigger and they do it a little bit differently than the neutrophils. Okay. The other type of leukocytes that we have is what is called a mast cell. And the mast cell produces a really important chemical, which is called histamine. So when we talk about histamine, we often kind of vilify histamine, right? Because we take antihistamines. It's like, oh, I'm having an allergic reaction, I'm going to take an antihistamine, right? But histamine is actually plays an important function in inflammation. So this is important in inflammation. So it allows your blood vessels to become leaky, fluid to move out of the blood vessels so that you can repair damaged tissue. So it's important in inflammation. We have one more type of leukocyte, which is actually not a cell, but it is a piece of cell and is called a platelet. So this is a piece of a white blood cell. And what do platelets do? They allow for blood to clot. So these cells are all produced from stem cells that are located in the bone marrow. So we have what is called hematopoietic tissue. So hema means blood, poetic means to produce, and this is tissue. So this is blood producing tissue. So this would be the bone marrow. Now, not all of our bones, specifically as adults, are capable of producing blood. Most of our bones are actually filled with adipose tissue. They're actually filled with fat. But we do maintain like our hip bones, and up here near our clavicles, we have some bones that produce blood. So this includes, this has stem cells that reproduce and produce specialized blood cells. So we're almost done with chapter 4. I'm just going to briefly talk about the different types of muscles and nervous tissue. And then we're going to move on to the integumentary system, which is your skin. So what I would do is I would read chapter 4, and I would take my quiz, my homework assignment on chapter 4. And then the integumentary system homework, I'm going to move. So I'll try to change it in both the Canvas and the mastering. So I'm going to move the integumentary to next Sunday, okay? So I'm moving the integumentary. You also have, let me look at your Canvas site. I think there's also something due this week, isn't there? I think there might be a Physio X that's due. Let's see. Okay. Yes. So for this week, you should do the tissues and the cell permeability and diffusion. And so the integumentary system, I'm going to move this to the 28th. I think I can do that right here. So you have 2 assignments. Oh, I can't edit. I'll edit it when I get back to my office. So the integumentary system will be the 28th. And then you have your histology extra credit that you could be working on. I think that that is open and you're able to work on that if you would like to do that this week as well. Okay, are there any questions? Nope, okay. So I will see you in lab on Friday.